Welcome, everybody, to our discussion on serverless data integration. My name is Zach Mitchell. I'm a big data architect with AWS Glue in AWS Lake Formation. And today, we're going to be discussing Glue. Specifically, our learning objectives today are getting a brief overview of what Glue is, just to refresh everybody's memory, discussing Glue and how it applies to different users, discussing Glue for different workloads, and how you can work with Glue for varying workload types. And then discussing how Glue can meet the requirements of your scaling needs. We understand workloads aren't always the same size. And so let's discuss that. And finally, we'll discuss Glue's centralized usage of a data catalog. So what is AWS Glue? As an overview, Glue is a fast, open, scalable integration service, as it says. We are a fully serverless data integration service built on the foundations of Apache Spark and Python. There is no servers or compute to manage. It scales as you need it, and you pay for what you use. The key capabilities of Glue include our scalable data integration engine with our built-in transforms designed for simplifying data integration tasks. Again, it's our serverless execution engine that is only charging you for what you need. And it's the ability to monitor all of those jobs in a centralized system and easily identify and troubleshoot issues. We have a centralized and unified data governance strategy that centers around the Glue data catalog that we'll get to in a little while. We have Glue crawlers, which simplify the ability to get data into the catalog and to have all of your data represented therein. And we have fine-grained security and access control by AWS Lake Formation. Glue allows you to connect to and ingest data from hundreds of different data sources. We have native connectors from the most popular systems like Redshift, Aurora, and MongoDB. And we have a connector marketplace for things such as SaaS providers like Salesforce. We also expose an API to allow you to easily build your own connectors through your own custom interfaces. Glue is not persona specific, and we're going to get into this today, ideally quite deeply. Glue is designed to be used by a variety of people to explore data, to help generate code when necessary, and to allow you to really dive in when you want to get your hands dirty. It allows you to work together and collaborate together, even when you have a variety of skill sets within a team. So let's get into the data integration overview first, because we can describe what Glue is, but let's take a step back and describe what data integration is and why it's necessary. Data integration is a loop. It's the process of discovering your data and combining that data, transforming it and cleaning it such that it makes sense for your business. So you can get quality, you can run useful analytics, you can build your machine learning models, so on and so forth. It involves centralizing that data, and that data centralization usually revolves around a catalog. I need to know what data I have. I need to be able to move that data from its original source and its original shape. I need to be able to change it to fit a different source and a different shape. And that, of course, requires me to be able to connect to those sources and those destinations. However, data integration is extremely hard. So if you don't get it right, you're going to get incorrect results. The problem is you want those results because those results provide meaningful insights. They provide increased collaboration once you realize that, hey, two teams are likely doing the same thing. And these all lead to faster decisions as you increase that collaboration and you gain faster and more meaningful insights. So why is it hard? The first reason it's hard, of course, is because data is growing and changing ever more. Is growing rapidly and exponentially. Data sources seem to crop up all over the place. When you think you finally understand where your data is, somebody brings in a new data source and you have to deal with it. And with increased diversity of sources comes a diversity in the style and type of data. No longer is all data sitting in a relational table in a database. Now you've got data in flat files, you've got data in semi-structured stores like OpenSearch, and even graph stores like Neptune. All of these have to be dealt with typically in different ways. You've got different personas who are now dealing with data. No longer is it simply one data engineering team that produces reports about the data. You now have personas at the business level that simply want to get into the data with no code or very little coding experience. You have developers, again, that original central team that still need to do their job and still need to do the deep dive and tinkering with the data they have. And then you increasingly have purpose-built users of data analysts and scientists whose sole job it is to go and look beyond the data that currently exists and derive, again, increasingly diverse insights from that data. You have an increased number of applications interacting with your data as well. More and more of those applications are becoming real-time or near real-time, and therefore are very SLA sensitive. And waiting a day or two or even an hour for data is no longer acceptable. Your applications are scaling ever more rapidly. And of course, as you're trying to balance all of these demands of time sensitivity and highly scalable nature of your data, you come up across budget constraints because these things cost money. And so how do you balance the needs of your applications with your budget? Well, the problem is traditional solutions aren't suited for this. You don't have a scalable infrastructure. Your infrastructure back in the day was complex to install and to maintain and was often very, very rigid. That rigidity came with a high cost, both a people cost in having to deal with it, as well as a cost for extra licenses for advanced functionality, for other transforms, centralized cataloging. You seem to need a different piece of software for each piece of your data infrastructure. And a lot of times that was all based off proprietary tooling that locked you in, and you were stuck. Your data was in and you can't go anywhere because your data is sitting in that engine. It becomes a critical component of your business. So against all this, how do you get all of this data into the hands of the right people? Well, that requires the right tooling. So let's get into the tooling that Glue provides. Typically in one of these presentations, I would actually go the simplest tooling to the most advanced. But today I want to work a little backwards to show you the simplification that can occur when we go from the advanced tooling that's built at a really low level to the simpler tooling that is built in toward no-code personalities. So our advanced tool, our most modern tool, is called Glue Interactive Sessions. With interactive sessions, we provide an interactive data integration experience. We provide interactive development of Glue jobs and interactive data exploration. Interactive sessions replaces Glue development endpoints if you've used those in the past. Interactive sessions provides the rapid creation of serverless Spark. You are able to launch an interactive session within about 30 seconds from the time you decide you want to go work with your data. You can configure and install any packages you need inside Glue's serverless environment right from the same place. And every time you go to work with interactive sessions, you get dedicated resources. You're not sharing a set of compute with your neighbor or your colleague. You're not sharing a set of compute with anyone else. It is dedicated to this specific task of your session. It's important to note that interactive sessions is extraordinarily cost effective. You literally only pay for what you use. Interactive sessions aggressively clean themselves up and time out, so you're not wasting idle compute. And all the billing is per second. The main interface into interactive sessions is a Jupyter kernel. It's easy to install on your local MacBook or PC. So you can run it locally. You can run it in the cloud, either on SageMaker or in Glue Studio. And because you can run it locally, you can connect it to your favorite IDE. So let's go ahead and dive in real quick and let me show you a demo of this kernel. Now, this particular demo I recorded a while back, but I recorded it on an airplane at 40,000 feet with no bandwidth because I was on an airplane. But I wanted to see if I could use interactive sessions from anywhere. And specifically in the use case, I wanted to go pull up a data set in the Glue data catalog. But first I need to configure my session. Sessions are configured via Jupyter Magics. Magics are simple commands that are prefixed with a percentage sign and allow you to specify the configuration of Glue and any setting you want in Glue. If you need to remember what magics are, you simply call help to see what you can do. Now back to what I was doing. So in sessions, I was looking for a table in the COVID-19 data lake when I was doing this particular demo. That's right, I was looking for the county populations table. Now that I remember the table name, I can go look at the data. So I'm going to use an SQL magic to select from the county populations table and look at the data. Sure enough, there it is. So now I want to see if I can find the largest counties by population. So I'm going to go again, run that query again, this time sorting by population estimate. Once I've sorted by the population estimate, you can see that the sorting is not correct. In this case, it looks like the population estimate was a string. And so we're going to import Glue, and we're going to use Glue's transformation engine to figure that out. Now, you'll notice I made a mistake. The beautiful thing about interactive sessions is if I make a mistake, I can simply correct it. I don't have to wait minutes in between mistakes to go fix them like I used to. So sure enough, I can see that county populations was a string. And I could go back and fix that string by casting it over to an integer using applied mapping. So that's what we're going to go do real quick. We'll go ahead and clean up the entire dynamic frame. We are going to rename the column to get rid of the spacing because nothing likes the spacing. And so now we're going to keep the two columns we had. Now that we're happy with the columns, we can go ahead and create a temporary view in a data frame to see if we can query on top of them. And sure enough, now county populations are properly sorted, and we can see the top 10 counties by population in the COVID-19 data set. It's worth noting that this entire demo was done sitting on an airplane. It was done sitting in Visual Studio Code. And so this is showing interactive sessions running in an IDE local to my MacBook, essentially being able to connect to Glue's distributed compute service from anywhere I have an internet connection. Worth calling out again is the configuration and why Jupyter Magics were used to configure interactive sessions. Jupyter Magics are, again, these snippets of code that state this is how I want my session configured. When they're run as the first cell, we take that configuration and we apply it to your Glue session and environment. These are the same parameters as you would use in a Glue job, if you're familiar with those. You can pass any configuration you need to Glue, including custom Spark config, in this case, enabling the cryo serializer. As long as you do that before running your first cell of code, your config stays and goes. If you forget something, say you forget the connection to your database, or you discover you need another database connection, no problem. Simply add it to your magic list, restart the kernel, and rerun your code. And within seconds, you have a brand new cluster with a brand new configuration, and off you go. The other thing worth calling out here is this particular configuration assumes I'm wanting to use Glue streaming. I can use interactive sessions with Glue structured streaming. Now, IS is really, really great if I'm a developer and if I love working in code. However, there are many customers who want to get the power of Glue and the flexibility of it without getting into the code. So that's what Glue Studio comes in. Glue Studio is our visual job authoring and monitoring tool. You don't have to write code. You simply have to drag and drop nodes. In Glue Studio, you can preview data at each step of the way. You get real-time schema inference. And just like the rest of Glue, it supports hundreds of connectors. And yes, you can still use transforms in SQL or custom code as needed if you have the capability and the desire to do so. While not required, they do come in handy when you want to do something that we don't support directly out of the box. Glue Studio also offers a monitoring environment for all of your jobs in Glue through a single pane of glass. Okay, let's get into a demo of Glue Studio. Let's go create a job with a visual source and target. This will pre-populate for us 3 nodes, a source, a destination, and apply mapping. So let's go ahead and select a source from S3. We'll go to the catalog table that we created out of the previous demo's data. So we call that demo populations. Now, before I can start a data preview, I have to fill in the rest of my information for my nodes. In this case, my S3 bucket needs a location to write data to. Once we've filled that out, we can go back to my source bucket and we can click data preview. And once we select a role, preview will start. It might take a few seconds, but within a few seconds, we will start to get a data preview. Data previews are powered by interactive sessions, the same things we've been discussing in the last few demos. Now, data previews are reasonably quick. The first one often takes a few more seconds to spin up the compute, but afterward, everything is very, very quick. We can see here that it's the same data we were working with earlier. Excellent. So let's go ahead now and let's add a transform. Let's go add a PII detection transform just for fun. And let's look for a person's name because we can select which ones we want. No, let's just go ahead and do all of it. Let's include all detection types. Let me just see everything. So let's go preview the data. Let's see if we can figure out what has PII. After giving it a second to load, again, we see the same preview. You'll notice that we're only previewing 5 of the 7 fields. So let's go ahead and select the rest of the fields. And you can see that detected entities says there are counties. The county column has a person's name in it. Okay. Is that really a problem? Let's go scroll over and find out. You can see that most of the county names are names. McCracken, Pope, Grant. They're county names. While they're detected by PII as proper names, they're not. But let's assume they were. Let's go ahead and redact them with a text field. So we're just going to asterisk them out. Let's preview the data again to make sure it was taken, and sure enough, there go the proper names. Any county that was identified as a proper name is gone. Awesome. Now, let's continue on, and let's assume we want to do something with this and write this out to our data catalog. Let's move that apply mapping back to our detect PII. You'll see the output schema gets rid of the detect struct because we don't want that in our output. We just want the clean data without the personally identifiable information. In this case, the county names that are proper names. And now that we're done with our data, we can select a bucket. We can select a database and a table we want to write to. In this case, we'll call it populations cleansed. And let's go ahead and save our transform. That's right. We need to name the job. Let's go ahead and call the job clean populations. Sounds good to me. And you can go look at the script. This script is generated dynamically every time you change a field or a property in the visual editor. Once we're satisfied with it, we can go to job details. All I'm doing today is enabling autoscaling. We'll save the job. And once we're happy with it, we can click run. Now, once we've run it, we can go to the run details page to get information on this particular run and how it's going. And if we wanted to keep going, we could go to schedules and we could click on schedules. It's worth calling out, in addition to the visual editor, Glue Studio offers Glue Studio notebooks. They're the same notebooks as interactive sessions locally, running in Jupyter. They're free, serverless, and they offer one-click job execution and scheduling. It's the same thing you saw me running in Visual Studio Code, except it's running in Jupyter Notebooks. They're sitting in Glue Studio, nothing for you to host, nothing for you to manage. The same magics that I was showing you earlier apply here and run in here. And of course, there are built-in monitoring support, just like there are for Glue jobs. Now, it's all nice and good that you can integrate your data in a batch mode, as we've been seeing, but what about your other data? Glue has several execution modes. We've got batch, which is your standard job that runs at a set schedule. You've got streaming modes that allow Glue to run continually, ingesting data as it hits a stream. You have event-based execution for Glue that will kick off a Glue job based off of an event trigger. And then you have an interactive API that allows you to integrate Glue into interactive applications. So let's talk about batch for a minute. Why batch? Simply, batch is there for scale and for reuse. It's the thing we typically think about when we think data integration or ETL. But batch goes beyond just a single job. Often it goes into workflows and pipelines as well. So let's talk about workflows. Glue workflows allow you to orchestrate jobs with Glue and with other AWS services. You can use Glue Spark jobs as well as Glue Python shell. You can monitor the execution of the entire workflow in one place. You can use triggers, either schedule-based, on-demand, or event-based triggers inside your workflows. And of course, you have easy access to monitoring and logs. The whole reason for workflows within Glue is to encapsulate the entirety of your data integration pipeline in one place. Now, workflows are great, but oftentimes you're repeating the same process. You might be repeating the same workflow for sales, for marketing, for another department. Now, these come with their own challenges. If you're repeating these continually, you're coding them manually, you're making mistakes because you have to change the same thing over and over again. You have some poor data engineer who has to do this 50 times in his job, and at some point it fails to scale. So how do we avoid that developer spending that valuable time? And how do we avoid the errors and the pain? Glue gives us custom blueprints. These are workflows that are templatized. You simply give Glue a script, a configuration file, essentially how you want us to prepare and launch the environment for your workflow, and a layout file to say, hey, what should the inputs and outputs to my workflow be? And we do the rest. You can then instantiate that workflow as necessary. So your end users can just say, cool, I need my daily report workflow for a new report. And they can fill in the boxes, click submit, and your Glue workflow creates a copy of itself with the correct parameters and does its thing. The next mode we talked about is streaming. Glue streaming is built on Spark structured streaming. It is fully serverless, and you can build jobs visually, interactively with interactive sessions, or in a more traditional manner like you have always done with an IDE in Spark. You can easily connect from Kinesis or Kafka directly in the visual editor. And so streaming is a great way to move your Spark jobs from batch into a micro batch and streaming method, because really the difference between streaming and batch is only a few lines of code. Glue makes it fairly easy to migrate from one to the other, either visually or in a traditional manner. The next method we discussed was event-driven integration. So how do we let your data drive your work? Glue ETL integrates now with Amazon Event Bridge. Amazon Event Bridge has hundreds of built-in sources, allows connections to custom applications in your SaaS applications. They provide all of these triggers that allow you to kick off a workflow that includes Glue jobs, crawlers, and other things. And the whole purpose of this is that you let your data do the work. You might have data that comes in daily. Once a day, it's sometime roughly in the evening. My clients upload their data to my S3 bucket, and I have to go get it. So every night I kick it off and I go get the data, and I hope it's all there. With Event Bridge, the second the data lands, you can go ahead and just get the data. You don't have to schedule it on a schedule. You can do it in response to the event of your data landing in your S3 bucket. This allows you to move closer to that near real time goal that everybody seems to be seeking without the great expense and hassle of maintaining a continually streaming environment when you don't likely need one for every use case. And finally, the last version that we'd like to talk about, the last method for integrating Glue, is interactivity, using interactive apps. Using Glue interactive sessions, you can integrate Glue directly into your own applications using the Glue APIs. This includes Glue streaming, and it allows you to extend Glue into any application that has access to AWS, on-premise or in the cloud. So let's go ahead and see how this might be done. So here I'm going to have a simple bash application called detect PII. And this is going to run what amounts to the same code we ran earlier, again, on the same table. I'm not trying to do anything fancy with data. And this thing's going to go out and it's going to run the detect PII systems against interactive sessions. And it's going to ask, hey, is this actually PII? Well, in this table, no. Queen Anne's, Maryland is a county. It's not PII. So we're just going to put no. Well, what about Castro, Texas? Is that a name? Well, no, again, it's a county. So no. And so on and so forth. Hamilton, South Dakota, no. Then there's no PII in here. At this point, I don't think there is PII, so I'm going to exit. Now, if there was PII, I could have said yes, and something else on my application could have happened, such as locking it down inside lake formation or notifying the data owner that they have potential PII within their data. While automatic detection is great and extremely useful, there are times that auditing is appropriate. So this is all nice and great, but how does Glue work? How does Glue do all of these things and scale from all of these personas and all of these workflows and use cases? Glue runs a scalable execution model where a job is kicked off by a job manager, and the job is divided into stages, and the data is divided into partitions. And the job manager takes those stages and pairs them with partitions to schedule tasks on a worker or a node of compute. And Glue serverlessly scales to thousands of workers and parallelly executes these tasks on the workers. And of course, you only pay for the compute that's used. Glue announced at reInvent, and we launched it at the San Francisco Summit, Autoscaling. And so now, in addition to just setting a serverless compute, you check the box, as I showed earlier, and we will only provision the compute you need for any given task. So let's dive deeper real quick into integrating at scale, because scaling challenges are hard. You've got different business events, schema and size variance, source variance, and this, again, all impacts your cost and capacity. You've got resource prediction problems, tuning's hard, and yeah, everyone typically over provisions because the last thing you want is for it to fail. I'd rather pay 20% more than have to be woken up in the middle of the night. So that's where autoscaling comes in. As discussed, autoscaling is a checkbox. It reduces cost. Simply put, you check the box and you don't have to think about the capacity planning. You enable autoscaling. You set the maximum number of workers you want to allocate to your autoscaling job, and you let it go. So let's go ahead and look at how autoscaling works within a multi-stage job. If we have a JDBC source and we want to read from it, apply a custom transform, a simple mapping, and write it out, you're going to have a few connections when you start the JDBC job. Then you're going to have high parallelization after the data is read into memory in Spark. Now, in a traditional cluster, without autoscaling, you would have to spin up all the workers first. Then you would have to do the small read and the big writes, and you'd have a bunch of idle compute. With autoscaling, we only have to provision the workers that need to do the read when it's time to do the read. When it's time to do the advanced transforms, we can scale up as needed, not before. And that way you're saving yourself significant compute and a good potential cost savings. Now, all of this is nice and good, but if I've got so much more data that I can interact with in my company, how can I unify that? How can I centralize all of my data and centrally govern it? Glue Data Catalog is our mechanism for central data organization. It is a meta store for data lakes. It's highly scalable and durable. It's extremely cost effective. It offers security compliance and auditing capabilities, and it is Hive Metastore compliant with an open source connector to attach all of your favorite Hive compatible systems. Now, easiest way to get data into your catalog is to use a Glue crawler. Glue crawlers are little serverless applications that connect to your data sources, automatically discover your schema and extract that schema. And then they write that schema into the data catalog. Every time they reread your data source, they will update your schema as needed inside the catalog. You're able to specify your own classifiers for custom files. This is a big deal because you can even use Glue crawler for those old school flat files with classifiers and Grok. This can allow you to remove some of your legacy systems that currently exist because it's really hard to deal with this old data. And of course, crawlers can run on demand as part of a schedule or part of a workflow or in response to events. Event-based crawlers on S3, for example, only crawl when a new object hits. Remember, there's no real such thing as an update in S3. It's a new object or not. So you can have a broader coverage with crawlers because you can say, hey, monitor all of these folders, these prefixes in S3. Let me know when anything changes. And because we're not having to list the buckets, crawlers become faster and more cost effective, making it easier to maintain your data lake at every stage in your data journey. Now, we also offer lake formation for fine-grained access control. And while I'm not going to go too deep into lake formation, I did want to call out governed tables. Lake formation governed tables are a table type on top of S3 that provides atomic transactions on top of your tables so that you can atomically maintain and update your objects. You can automatically compact your data as necessary to make sure it's performant for these distributed analytics applications such as Amazon Athena, and allows you time travel in your table. So you can look at the table and the data as it existed at any given point in time. This allows you to do cleaner testing of ML models and training. It allows you a better understanding of when your data has come in and how it's come in, and be able to compare what's changed when. There are a lot of advantages to automatic time travel within your tables. Thank you all for coming. I hope you've learned something. I look forward to seeing what you guys build on AWS Glue. Thank you very much.